Hello, so this last video for today's lesson is going to cover a mole-to-mole conversion problem. So we are on page, I guess you don't really have pages, but we're on the conversions using moles, sample problem A in your note packet. And it should read how many moles of lithium hydroxide are required to react with 20 moles carbon dioxide, the average amount exhaled by a person each day. So this problem is relating to spacecrafts because the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide according to the following chemical equation. So you are given this equation to solve this problem, which is a super important piece that you need to know. So I'm going to follow along with you with this problem on the board behind me so that we can solve this together. So let me go ahead and write out our formula because as usual I'm not prepared. So we have this formula. We have carbon dioxide gas reacting with 2 copies of lithium hydroxide solid to create solid lithium carbonate and liquid water. So in our problem, it's asking how many moles of lithium hydroxide, and how many moles of lithium hydroxide are required to react with 20 moles of CO2. So this 20 moles we would circle because that's our given. That's what we're starting with. We always start with our given. And we're looking for moles of lithium hydroxide. So this is going to be a little bit different than what we learned last unit because here we're starting with moles of CO2. And we're finding moles still, so we're not changing the unit of moles, but we're going from CO2 to lithium hydroxide. So we're changing the unit that we're moving between. Okay, so let's go ahead and I'm just gonna walk this through with you. So we're gonna start with 20 moles of CO2. I know last unit I told you it was gonna be really important to write your units out. But this unit, you can't just write just the unit, but you also have to write what the compound is attached to that unit. Okay, so we have 20 moles of CO2, and then go ahead and make your bracket for dimensional analysis. So we have moles of CO2 on the top. Remember, when we want to cancel units, we need to also have that unit on the bottom. So if we have moles of CO2 on the top, we need to have moles of CO2 on the bottom. Okay, in our last video, we talked about mole ratios. A mole ratio, remember, relates the moles of one thing to the moles of another. So what might be a mole ratio between carbon dioxide and LiOH? Hopefully your mole ratio would be 1 CO2. Oopsie. This is a mess. 1 mole of CO2 is equal to 2 moles of LiOH, or 2 moles of LiOH is equivalent to 1 mole of CO2. So these mole ratios are what our conversion factors we're going to use. And you can determine which one you're going to use because we know we need moles of CO2 on the bottom. And we have moles of CO2 on the bottom in this conversion. So we're going to have 1 mole of CO2 on the bottom and 2 moles of lithium hydroxide on the top. Okay, we can cancel out our unit of moles of CO2, and we're left with moles of lithium hydroxide, which is what we're looking for. To solve this, we go ahead and just multiply across the top, so 20 times by 2 is going to be 40 divided by 1, so we have 40 moles, oh, it's getting a little cut off there, of lithium hydroxide as our answer. Okay, let me know if you have questions on that one. Let's go over another one together. So let me go ahead and pause it and erase this. Okay, hopefully you're following along in your note packet, and if you are, this is the next formula that's given to you in sample problem A, number 2. And the problem reads, if we have 2 moles of N2 reacting with sufficient H2, how many moles of NH3 will be produced? A couple things I want to talk about before we start this problem. The first one is that in our equation, we must always start with a balanced reaction. Okay, you have to have a balanced reaction to ensure your mole ratios are correct. So when we're looking at this reaction, we have 2 ends on a reactant side and 2 ends on our products, 6 hydrogens on our reactants and 6 hydrogen on our products. So that means we are good to keep going. We can solve this problem. Another thing I want to quickly talk about is in the problem it reads, if we have 2 moles of N2 reacting with sufficient H2. What does the word sufficient mean? Okay, sufficient means we have enough, so we can kind of ignore the H2. It doesn't really play a role in this problem. But we're looking for moles of NH3 and we're given 2 moles of N2. So I want you to go ahead and pause the video and try to solve this problem on your own. Okay, and again, I will show you this problem really quick. We are looking at this problem here. So go ahead and check out this problem, pause the video, and solve this on your own. Oops. Let me make this big again. Maybe. Come on, come on. There we go. So, let's solve this. We are starting again with 2 moles of N2. Hopefully you've recognized we have moles of N2 on the top of our reaction. We need it on the bottom, so we can cancel those out. In our conversion factor, our mole ratio between N2 and NH3 is 1 mole of N2 is equivalent to 2 moles of NH3. Okay? However, we need to flip this because we need to have 1 mole of N2 on the bottom and 2 moles of NH3 on the top. We can go ahead and cancel our moles of N2, so we're left with 2 times 2 divided by 1. So our answer should be 4 moles of NH3. And that's ammonium. 4 moles of ammonium. Okay. If you have questions, make sure to reach out about this. I do want to focus really quick and encourage you to continue working on your practice book. Okay, so make sure you're adding to your practice book. Go ahead and add a page of how to go from moles of one thing to moles of another thing. If you have questions on what this practice page should look like, go ahead and email me and I can send you an example. Have a good day. Bye.